Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Trigonometry series and concerns the cosine rule. This guide introduces the cosine rule and illustrates the specific situations in when and how it can be used to solve problems involving triangles which do not contain a right angle. Introduction. Problems involving triangles are extremely common in many mathematical subject areas, including geometry, vectors, calculus, and complex numbers. Many such problems involve right-angled triangles and can be solved using the trigonometric ratios. See study guide, Solving Right-Angled Triangles. You should be comfortable solving right-angled triangles before continuing with this guide. It is also common for problems to involve triangles which do not contain a right angle. To solve these types of triangles, you need to use the more general mathematical rules of either the cosine rule or the sine rule. You cannot use the trigonometric ratios or Pythagoras' theorem in these cases. The table below shows all the triangles problems that are possible and the method you can use to solve them. For right-angled triangles, when you know two sides, you use trigonometric ratios. For right-angled triangles, when you know one side and one angle, you use trigonometric ratios. For non-right-angled triangles, where you know three sides, use the cosine rule. For non-right-angled triangles, where you know two sides and an included angle, you use the cosine rule. For non-right-angled triangles, where you know two sides and a non-included angle, you use the sine rule. Non-right-angled triangles, where you know one side and two angles, use the sine rule. For any type of triangle, where you know three angles, you cannot solve the triangle. The cosine rule is given by a squared equals b squared plus c squared minus 2bc cos a, where lowercase a, lowercase b and lowercase c are the lengths of the sides of the triangle and uppercase A is the angle opposite lowercase a. The angle uppercase A is sometimes said to be included by lowercase b and lowercase c. This study guide offers help with using the cosine rule. There is a separate guide for help with the sine rule. See study guide, the sine rule. To use the cosine rule effectively, you should be comfortable with the manipulation of equations. See study guide, rearranging equations, for help with this. You can see from the table on the first page of this guide that you should use the cosine rule to help you solve a triangle if you know the lengths of all three sides, or if you have the length of two sides and the size of the angle between them. As with all questions concerning triangles, it is a good idea to sketch the triangle you are investigating and label the quantities you know as part of answering the question. Example: finding the size of angles using the cosine rule. Solve the triangle with sides 9.2 cm, 12 cm and 20.5 cm. If you have the lengths of the three sides, you can use the cosine rule to calculate any of the internal angles of the triangle. You can do this twice and then use the fact that the angles of a triangle add to 180 degrees to find the third angle. Start by sketching the triangle. It does not matter if it is not accurate, but you should try to get the longest and shortest sides to correspond with the biggest and smallest lengths. Here is the triangle. The shortest length is 9.2 cm and this has been labelled the shortest side. The longest length is 20.5 cm and this is given the longest side. And the other length, 12 cm, has been labelled to the remaining side. As you have all three sides, you can use the cosine rule. Follow this method. 1. Decide on the angle you want to work out, it does not matter which, and label it uppercase A, like this. Label the side opposite this angle as lowercase a. This is important, like this. Label the other two sides lowercase b and lowercase c. It does not matter which way around, like this. Which means that lowercase a equals 9.2 centimetres, lowercase b equals 12 centimetres, and lowercase c equals 20.5 centimetres. Now substitute these values into the cosine rule given on the first page of this guide. Lowercase a squared equals lowercase b squared plus lowercase c squared minus 2 multiplied by lowercase b multiplied by lowercase c multiplied by the cosine of uppercase a. Therefore, 9.2 squared equals 12 squared plus 20.5 squared minus 2 multiplied by 12 multiplied by 20.5 multiplied by the cosine of uppercase a. So 84.64 equals 144 plus 420.25 minus 492 multiplied by the cosine of uppercase a. The only unknown quantity is uppercase a, and so you can rearrange the final equation to give the cosine of uppercase a equals 84.64 minus 144 minus 420.25 all divided by minus 492, and this equals 0.97. And so uppercase a equals the inverse cosine of 0.97, which equals 12.89 degrees. You can repeat this procedure to find another angle, and remember you will label lowercase a, lowercase b and lowercase c differently because you are finding a different angle. So here is the triangle, and you have just calculated that this angle is 12.89 degrees. So now let's calculate this angle, labelled uppercase a. Label the side opposite, which is this time is 12 centimetres, as lowercase a, and label the other two sides as lowercase b and lowercase c. It doesn't matter which. So label 9.2 centimetres as lowercase b and 20.5 centimetres as lowercase c. So this time lowercase a equals 12 centimetres, lowercase b equals 9.2 centimetres and lowercase c equals 20.5 centimetres. Now substitute these new values into the cosine rule given on the first page of this guide. Lowercase a squared equals lowercase b squared plus lowercase c squared minus 2 multiplied by lowercase b multiplied by lowercase c multiplied by the cosine of uppercase a. Substituting in, 12 squared equals 9.2 squared plus 20.5 squared minus 2 multiplied by 9.2 multiplied by 20.5 multiplied by the cosine of uppercase a. So 144 equals 84.64 plus 420.25 minus 377.2 multiplied by the cosine of uppercase a. Again, the only unknown quantity is uppercase a, and you can rearrange the final equation to give the cosine of uppercase a equals 144 minus 84.64 minus 420.25 all divided by 377.2, which equals 0.96. And so uppercase a equals the inverse cosine of 0.96, which equals 16.91 degrees. You can use the fact that all the angles in the triangle add to 180 degrees to show that the final unknown angle is 180 minus 12.89 degrees minus 16.91 degrees, which equals 150.2 degrees, to solve the triangle as shown on the next page. Here is the fully solved triangle. Example: finding the length of a side. Solve the triangle with sides of length 4 cm and 6 cm, which includes the angle 120 degrees. If you have the lengths of two sides and the angle included by them, you can use the cosine rule to calculate the length of the third side. Again, you start by sketching the triangle. It doesn't matter if it is not accurate, but you should try to get the longest and shortest sides to correspond with the biggest and smallest lengths. Like this. You can see that the angle 120 degrees is in between or included by the sides 6 centimetres and 4 centimetres. To find the length of the other side, you can follow this method. 1. Label the angle you know as uppercase A. This is important. Like this. Label the side opposite this angle as lowercase a. This is also important. Like this. Label the two sides you know as lowercase b and lowercase c. It does not matter which way around. Like this. Which means that uppercase A equals 120 degrees, lowercase b equals 4 centimetres, and lowercase c equals 6 centimetres. Now substitute these values into the cosine rule given on the first page of this guide. Lowercase a squared equals lowercase b squared plus lowercase c squared minus 2 multiplied by lowercase b multiplied by lowercase c multiplied by the cosine of uppercase A. Therefore, lowercase a squared equals 4 squared plus 6 squared minus 2 multiplied by 4 multiplied by 6 multiplied by the cosine of 120. So, a squared equals 16 plus 36 plus 24, which equals 76. By taking the square root of each side, you'll find that lowercase a equals the square root of 76, which equals 8.72 centimetres to 2 decimal places. As you now have all three sides, you have just discovered that this side is 8.72 centimetres. You can find either of the unknown angles using the method from the previous example. 1. Decide on the angle you want to work out, it doesn't matter which, and label it uppercase A. Like this. Label the side opposite this angle as lowercase a. This is important. Like this. Label the other two sides lowercase b and lowercase c. It does not matter which way around. Like this. Which means that lowercase a equals 4 centimetres, lowercase b equals 6 centimetres, and lowercase c equals 8.72 centimetres. Now substitute these values into the cosine rule given on the first page of this guide. Lowercase a squared equals lowercase b squared plus lowercase c squared minus 2 multiplied by b multiplied by c multiplied by the cosine of uppercase a. Therefore, 4 squared equals 6 squared plus 8.72 squared minus 2 multiplied by 6 multiplied by 8.72 multiplied by the cosine of uppercase a. So, 16 equals 36 plus 76 minus 104.64 multiplied by the cosine of a. 16 equals 36 plus 76 minus 104.64 multiplied by the cosine of uppercase a. The only unknown quantity is uppercase a, and so you can rearrange the final equation to give the cosine of uppercase a equals 16 minus 36 minus 76 all divided by minus 144.64, and this equals 0.92 to 2 decimal places. And so uppercase a equals the inverse cosine of 0.92, which equals 23.45 degrees. You can use the fact that all the angles in a triangle add to 180 degrees to show that the final unknown angle is 180 degrees minus 120 degrees minus 23.45 degrees, which equals 36.55 degrees, to solve the triangle as shown below. Further guidance and information. If you have any further questions about trigonometry or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor, or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592761, email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.